Welcome to the firm, everyone. Go ahead and grab a seat. I'm your lead safety consultant, and this explainer is your official orientation into the incredibly high-stakes world of industrial safety management. Your internship? It starts right now. Out there on the factory floor, out on the oil rigs, the construction sites, our job isn't just about checking off boxes on a clipboard. No, our job is literally to make sure every single worker goes home to their family at the end of their shift. It's a huge responsibility. Okay, let's dive right in. Here is our training schedule for today. We're going to start with your safety training rules, then move into core rules and hazard avoidance. After that, we'll crunch some numbers and calculate safety incidence rates, explore mechanical and environmental controls, and finally look at learning from catastrophic disasters. This is your strict schedule before anyone even thinks about stepping foot onto a site. All right, Section 1, your safety training rules. And listen, safety discipline doesn't just magically start out in the field, it starts right here, today, in the classroom. So let's lay out your mandatory training protocols. In our industry, cutting corners gets people hurt, right? So we absolutely do not tolerate it here either. Do not fake attendance for yourself or your friends. Seriously, that is exactly like falsifying a safety log out in the field, and it's totally unacceptable. Also, no entry allowed after 10 minutes of the lecture start. You're late, you're out. There are 0 makeup exams and no delayed assignments will be accepted whatsoever. For your grades, you can expect 2 to 4 assignments and 2 to 4 quizzes for your year work marks. Oh, and be ready for verbal tests on your weekly readings at literally any time. Show up, do the work, and you'll pass. Simple as that. Now, organization is going to be your absolute best tool for survival here. You've got to keep one complete, dedicated notebook ready for this course. Take detailed notes during every single lecture and do all your practice work in that exact same notebook. Keeping all your data, your formulas, and your observations in one central, reliable spot, well, that's exactly how a professional safety engineer operates in the real world. So, with all these strict rules, the assignments, the pop quizzes, you might be wondering, how exactly are you expected to track your progress and actually submit your work? The answer is strict digital compliance. You need to keep your contact fresh by checking the course webpage frequently. If you're unsure about something, ask. But here's the kicker. You must only access and submit all of your work on your designated group page. Please don't hand me loose papers. We use these specific digital systems because out in the real world, proper documentation channels are legally binding. Okay, moving right along to Section 2, core roles and hazard avoidance. Let's actually talk about what this job entails once you finally graduate from this classroom. What's really fascinating about the safety and health manager role is that it's vastly misunderstood. You might be thinking your only job is walking around a factory floor pointing out dangers, right? But in reality, you're a professional wearing several different hats. You're taking on legal compliance, administrative duties, and you're working directly with top management. You are essentially the crucial pivot point between keeping the facility legally compliant, keeping the workers safe, and making sure the business can still actually operate. And that brings us to a pretty harsh reality. We cannot eliminate all and every hazard at the workplace. We just can't. If you think you can, you're kind of living in a fantasy. Because honestly, the only way to eliminate 100% of the risk in a steel mill is to completely shut down the steel mill. Our real job is about making tough, calculated, pragmatic management choices. So how do we make those real-world choices for hazard correction? When we spot a hazard, we put it into one of 3 buckets. First, we have hazards that are just physically infeasible to correct due to the nature of the work. Second, we've got hazards that are physically feasible to fix, but economically infeasible, meaning the solution would literally bankrupt the company. And finally, the third bucket, hazards that are both physically and economically feasible to correct. That third group, that's our primary strike zone, where we implement immediate controls. All right, let's shift gears to Section 3, calculating safety incidence rates. As safety consultants, we live and breathe data. And OSHA, that's the Occupational Safety and Health Administration, they require some very specific logging. Now, before we do any actual math, you need to burn this number into your brain, 200,000. In all your OSHA calculations, this is your baseline constant. Why 200,000? Well, it represents 100 employees working 40 hours a week for 50 weeks a year. We use this exact constant to normalize incidence rates across companies of all shapes and sizes. It lets us compare a small 50-person shop directly against a massive 10,000-person corporation on a totally even playing field. Let's see how this actually works for a sample 50-employee firm. If you're calculating the total injury incidence rate, you take your total injuries, but here is the crucial part. You exclude any fatalities. So 4 total injuries minus 1 fatality multiplied by our 200,000 constant and then divided by the total hours worked by our 50 employees, which is 50 times 2,000. That gives us a rate of 6. For the total illness incidence rate, it's 5 illnesses times the constant divided by the total hours, giving us 10. Now, for the lost workdays rate, notice that you must count restricted days along with the completely lost days. So that's 67 plus 16 times the constant divided by total hours, giving us 166. And for the lost workday injury rate, the LWDI, remember to exclude injuries with no lost workdays and fatalities, so it's 1 times our constant divided by total hours, which is 2. Understanding these exact exclusions, like dropping fatalities from certain rates, is absolutely essential for accurate federal reporting. Okay, moving on to Section 4, Mechanical and Environmental Controls. Let's get our heads out of the math for a second and step onto the factory floor to see how we actually mitigate these hazards. The most basic, fundamental line of defense is PPE, personal protective equipment. We're talking hard hats, safety goggles, earplugs, but here's the thing you have to remember. PPE is the absolute last line of defense between a hazard and a worker. Our ultimate goal as engineers is to control the hazard way before it ever even reaches the worker's gear. Let's look at how this hierarchy plays out with machine guarding. You could just slap up a passive warning sign telling a worker to keep the safety guards in place, but that relies entirely on human compliance, right? Contrast that with an active light curtain on a massive hydraulic press. This is a true physical, active control. If a worker's hand breaks the plane of those lasers, the machine instantly and automatically shuts down. It takes human error completely out of the equation. And honestly, that is the gold standard for mechanical hazard avoidance. But what about environmental controls? Say you've got toxic dust in the air. The obvious solution is exhaust ventilation. Just pump that bad air outside. But there's a huge catch. In the dead of winter, if you're pumping all your factory's air outside, you are basically throwing massive amounts of expensive heating energy right out the window. So, we've got 3 brilliant engineering solutions for this. Solution 1, design systems to filter, purify, and recycle that contaminated air back into the plant. Boom, you keep your heat. Solution 2, introduce unheated makeup air directly adjacent to the contaminant's origin point so it gets sucked right out before it ever mixes with your expensive heated factory air. Or, Solution 3, use a heat exchanger. You use the hot, outgoing exhaust air to warm up the cold, incoming makeup air without actually mixing the contaminants. It's a really elegant blend of safety and economics. All right, we've reached our final section today. Section 5, Learning from Catastrophic Disasters. I want to slow things down right here because this is the moment where all this theory becomes life and death. When safety management fails, the results aren't just bad, they're catastrophic. As a core part of your training, you're going to be required to analyze massive industrial failures. Take a look at the devastating port explosions in China and Beirut. Both of these catastrophes involve the improper storage of highly explosive materials. But as safety engineers, we don't just stare at the blast radius. We analyze the massive systemic failure points. We're looking at the breakdowns in administrative controls, the failures in hazard identification, and the lack of government compliance that somehow allowed thousands of tons of volatile chemicals to just sit unchecked right next to civilian populations. For your historic incident investigations, you'll be diving deep into a couple of major case studies. First, the Piper Alpha disaster. You'll need to determine exactly what happened and figure out how to engineer prevention protocols so it never, ever happens again. You'll also be analyzing the Exxon Valdez oil spill, focusing heavily on the systemic human failures, the massive environmental impact, and future avoidance protocols. Listen, your goal here isn't just to write a history report on what happened. It's to figure out how to prevent it from happening tomorrow. That is the absolute core of hazard investigation. So I'm going to leave you with this final assignment for your notebooks, and I really want you to discuss this with your peers before we meet again. What are the top 3 industries in terms of the number of incidents and fatalities over the last 3 years? Look up the data, verify those findings with your group, and then I want you to ask yourself a very serious question. If you get hired to consult for one of those top 3 dangerous industries tomorrow, where do you even begin? All right, class dismissed. I'll see you all on the group page.